Hi everyone, and welcome to my talk about BloC library. What is BloC library? Is a library that lets you handle the state of a Flutter application in a simple way. So before we start talking about BloC library, we need to better understand what is the state in Flutter. In Flutter, the UI reflects the state of our application. This means that when something changes inside our application, the UI will change accordingly. For example, if the state of our user change, the user is connected or not connected, the UI can be rebuilt based on that new state. How you should do that? Usually when something changes, you can call the setState method of your stateful widget that let the widget tree know that that part of the tree may be rebuilt. What happens is that while this is simple to use for simple cases like a button that should become active or not when tapped, when we start having some more complex UI that span in several widgets, we may need something more complex to handle that. First, we need to differentiate between the ephemeral state and the app state. The ephemeral state is the UI state, basically, because it's something that is not stored, should be contained in a single widget, and has no need to be serialized. One example of the ephemeral state, a classic stateful widget, where we have our widget and the state of the widget. In this case, as I said, we can use the setState to update the widget itself and all of its child. While the app state is for some complex cases like when we need to store the information that we are using. For example, the user online status. I'm online, I'm not online, because this information can be used everywhere on the application. Also, why we need to store side information, because if we close the app, we may need that information later when we reopen that. Some example can be the shopping cart in an e-commerce app. When we put the item on the cart and we want that to be stored, because if we receive a phone call, for example, we open again the application and we want again to see what we put in the cart and not a fresh state. Then the question is, why BloC? We have several options when dealing with state. As I said, we have the setState, the most simple form. The setState, however, doesn't let you out of the box to store data, for example. But we can use several libraries. There is Redux, there is Provider, but I find that BloC had the several advantages about that. First of all, it's simple and easy to understand. It's scalable because you don't need to use BloC for everything, but at the same time, it's simple enough that if you want to use a BloC for a small part of the application, you can do that. But if you need to do a BloC that spans across all your application, you can simply do that as well. So it's fine for small widget and big widget tree. It's predictable because, as we will see later, we always know how the BloC will behave in response of some action from the user. And this is testable because the BloC library is made by exposing some widget that you can use during the writing of your test. So let's see how the BloC works. Basically, the BloC works by separating the UI from the logic. In this case, BloC means business logic component. How it works? Basically, if you are familiar with the stream concept, this will be more easy for you. The streams is a method, class that you can use to have a value updated during the time. For example, let's take the future as a sample. In the future, you call your function that return a future, and you know that sometime in the future you will have the return value. In the case of the stream, you can use the keyword yield. Basically, in the case of the stream, you will have a several number of yielded values. It means that if you have an initial value, you can continue to listen to the stream to have several values returned in some point of time. To declare a method that returns a stream, you should use the keyword async with an asterisk, and it will return a stream of the type you want. Then, inside your method, you can use the yield keyword in order to have the result. This means that if I'm listening to the stream, mostly done by a stream builder widget, we will see that later, you will have, in this case, a number of return equal to the max value that we pass. For example, as I said before, we can use a stream builder to create a simple countdown widget. This is our stream. As you can see, I just added a future delayed await just to make the event loop wait for 1 second before the next yield, otherwise it will be more or less useless. And I used the stream that I created in my stream builder. I passed this it's as a parameter of stream for the stream builder. As you can see, I set 10 as a time that I want to wait. What will happen in the UI? It happened that the application is the widget is rebuilt every time the streams yield a new value. So when you print the value of snapshot, we will have a decreasing value over time. 10 the first time, then until 0 it will decrease by 1 every second, because I put the await there. So, how can we obtain the same by using BloC? First of all, let's separate the things. We need a BloC class. A BloC class extends the BloC and accept event as input and will return new state in a stream. As we can see, this is our counter block that extends BloC, and we have two parameters. One is the first is the event. Basically, we extend the generic of the block to say our event will be a counter event type. This is a class that I defined. We will see that later, and it will return a stream of int, because if we need a counter, we need an integer. So, as we said, the BloC accepts event to be changed. Basically, the event can be any class, as I said. It will be added to the BloC, and it will make it change its state. Let's see how. Why I said it can be anything else, and why I decided to use a counter event class that does basically nothing. Because by doing so, I can extend my class. And in my BloC, I can listen in the map event to state method. This is a method that we need to override in order to have the BloC working. We can discern what the event that reached the BloC is. For example, in this case, we can have an increment counter event that extends our counter event. Since increment counter is still an instance of counter event because the inheritance, we can handle that case in particular. Then, after we handle the event, we need to do something with the state, because the state must change, and we should update the UI with that. Even the state can be any class. For this sample, we used int, but we can do everything else. Because, for example, we may have a user. The user can change his online status. The user can change his nickname, can change some other information like email, phone number. But every time something changes in that class, we can yield a new state with the new class. How we do that? As I said, the second parameter of the block generic is an integer because we decided so. In the constructor, we need to call the super to pass the base state of our block. If we decided to have it null, we can do that. If we decided to not having null, here we should pass a value. And we will have, as a return in the map event to state, a stream with the type of our state. Then, since we marked the map event to state async with an asterisk, we can yield the state. As you can see here, I yield directly the state modified by the new value. State is a parameter, a field that you already have inside the block. And this means that when you yield the new state, you can use what you already have in order to modify it. In this case that we are doing the sample, if we increment the counter, we can yield the same state by adding 1, and if we decrement the counter, we can yield the same state decrementing by 1. What it means? That if I send two events of type increment counter, I can stay sure that they will be resolved in the same order. So if I have a state of 5 and I send two increment counter event, I will have first a yield of 6 and then a yield of 7. This is why I said that is predictable. And then we should list these change in our UI. This is split into parts. The first is how we provide the block to our UI. Because we have one block, we should say to our UI, use that block to check your state. And then we will have a series of widgets that we use to listen to those changes. First of all, let's see the widget that we can use to listen those changes. How we can build a new widget? We have the block builder. The block builder is a widget that is basically typed with the same block that we have and the state. The first parameter is the block, the second is the state. As you can see, the block builder doesn't need to be aware of the event type because it doesn't need that. It needs to be aware of the type of the state because it will be returned in the builder function, and it needs to know the block class because, as we will see later, these will be used to check which block will be used from the tree. Then where we have a builder function, mostly like the build function of our widget, we have the builder function. The builder function uses a context as a first parameter and a state as the second. The state is what the current state in the current block in the counter block is. So when you return the our widget, we're using the state as a parameter. For example, in the case of the counter, we just use the text as is. We can see that when we increase the counter, the builder will be rebuild the UI, and then we will have the value in our text. We may have some other things that we can do with the block. For example, if we don't want to change the UI, but we just want to react to the UI, we can use a BlockListener. As you can see, the main difference, I used a connection block for this, is a made-up block. Consider that it just tell you in the state if the user is connected or not. In this case, we have two parameters, the listener and the child. What's the difference? The difference is that when the state change, the child will not be rebuilt, because this is not a block builder but just a listener. It means that the child can even be a constant child, because it won't change unless we don't want that to change for other reasons. But we have a listener. In the listener, we can have the widget reacting to something. This something is a change in the state. We can simply check what we want to do. For example, the state of connection changed. I want to show a snack bar in our scaffold in order to tell the user, hey, now you are online, now you are offline. This is also easy because the block will never yield the same state twice. So we are sure that even if we have a connection check every 1 second, we will have the new state yielded when the previous state is different from the newest state. Now, in some cases, we may need to combine the two. Of course, we can nest the two widgets, so we can have a BlockListener that notify us in a snack bar, for example, that the value changed, and inside of that we can use a block builder to rebuild the text with our state. But we can do this in a simpler way, of course, by using the BlockConsumer. BlockConsumer basically is a widget that uses the property of the listener and the property of the builder. So inside the BlockConsumer, we have a listener function and a builder function. This is useful when we still want to change the value. For example, in the UI, we want to update our counter and want to send a message to the user by not rebuilding the UI, for example, by using the snack bar. Other than that, we can use the listener, for example, for some navigation-related task. For example, if the user is no longer connected, navigate outside of this view. Meanwhile, show my state in the UI. But of course, these make you ask some question like, how can I optimize that? Basically, we can optimize the changes by using the listen when, build when function. Those functions are parameters either of the block builder or the block listener, and of course of the BlockConsumer. Basically, either in the listener or the BlockConsumer, we can add a listen when function. As you can see, the listen when function is a function that returns you a previous and a current state, and you can use that in order to have more control on when you want to build that. For example, to listen that. For example, counter, I want to show a snack bar only when the new state is 10. So if we put the listen when, we can add as many events as we want. We are sure that the listen function will be fired only when the condition on the listen when are met. The same for the build when. Now we need to understand how to provide blocks, because we talked about the block builder, we talked about the block listener, but we don't know how still set the correct block to our widget. We have several ways. mostly two. The first is the direct mode. So basically in our block builder we just add the block parameters and say this widget starts with a counter block of 0. And will be the basic value of our block. So everything inside will be rebuilt with this value and will react, all the child of this block will react to that. But often this is not what we really need. So as I said, we pass it as a parameter and we use that. But what if we need to, for example, have a whole route depending on a block? For that, we can use the block provider. The block provider basically is another widget that we use to wrap our widget. Remember that when you use something like a block provider or a scaffold, you need a certain degree of separation from the widget that you are using, the widget that you are providing. Because when we use the callback that we'll see later to obtain the widget, the block, we will use an inherited widget mechanism, mostly used by insider by the provider part of the library. And if we use the same context that is creating the block provider, we will not have the block available. So either or we use a builder or we separate our widget that need to use the block in another widget. Like in this case, I wrapped my whole widget in a counter widget, and outside of that, I used a block provider. The block provider have a create function that give us the context as a parameter and want a block, and then our block as a return. Inside the child of our block provider, we set our widget, and this means that we are almost ready to work. We didn't saw just one thing: how to send the event. Because as we said in this scheme, we have a block. The block send its current state to the UI that show accordingly. But what we're missing here? The user do something in the UI that trigger an event that should update our block. As we said, the counter block, or the block in general, use inside a provider implementation in order to check the correct instance of the block that you need. What this means? This means that if you have a block, this means that if you have a block over your widget, you will be able to use the block provider of the type of your block context. This means that if you have this counter block, all the widget under that will be able to obtain the block instance by calling this method. Remember that since the child of the widget are available for the block, only those child or grandchild of that widget will be under that block. The rest of your tree won't have access to that. So if you call the block provider of counter block context in the left tree, you will get null. So let's see that we want a button that I called counter add and we want set button to increase the value of our counter. For that, I create an elevated button, and on the onPressed, I just get the instance of our block and add an event instance. This is useful because, as I said, it can be everything. So I can even put some parameters on the increment counter, and then I can use that inside the map to event to state method of the block. In this simple case, we just add an increment counter instance. And what's happening in our widget tree? We have our elevated button now added to the widget tree. I press the button. When I press the button, I call the block provider of counter block context add increment event. This will go up to the tree to the first instance of our block. Our block we yield the new state, because if you remember the sample that I wrote before, when we have an increment value, an increment event listened from the block we yield the state +1. This means that any child of our counter block will be updated with the new value. So remember that when you send an event, the event go always up to the tree, up to the first instance of the block that we need to. Then from the block, we go down into the tree to all the widgets that are under that block. As before, all the widgets that are not under the counter block in the tree will not be updated. Do we have some pitfalls while using BloC? Of course. Remember that the block builder or listener can be not a child of the correct block. In the previous example, I told you this. Basically, if you have a child that is a block and another child on the same level that has not that block, we can use the block provider off to get the instance only on the tree part that is directly child of said block. Another common pitfall is same state is never yelled twice. This can seem obviously, but in some complex case we may have some confusion because it's easy to have an integer that if we don't change the integer, we don't yield the new state, and this is super easy. But what if the class is a complex class? For example, a user. If we have a user, we need to be sure to or either implement the equatable library in order to assure that two instances of the user are different, or we need to make some other change like copy the value to assure that the new state is changed. Because if we trigger the quality check, for example, by changing the user name, but we didn't manage the quality check and the same instance we return it's equal, we will not have the new state yielded. This is one of the most common issue that you will encounter with the block. Because, for example, if you have a list, you add as your state, you add a new item on the list, but you don't copy the list, you will have an inequality of the two lists, because you are not deep checking inside the list, and this will let your state not get updated. And then another common pitfall is that nested widget can see only the nearest block in the tree. So if for some reason you have two counter block, one nested inside the other, only the widget under the various block will see only the first one they encounter going up into the tree. That's all for my talk. Thank you for listening, and I wait for you in FlutterExp devs if you speak Italian, or check on my Twitter. I will answer your question. Thank you, everybody. Bye.